Hello, student. My name is Odusonya Olalekan Adiola, your favorite chemistry teacher. This video is brought to you by Agotha Virtual Learning. And in today's class, we are going to be looking at the physical and the chemical properties of acids and bases. In today's class, we will look at the physical properties of acids, the physical properties of bases, the chemical properties of both acid and bases. And then at the end of the class, you are going to be looking at, or you are going to be doing a comparative study of the properties as an activity for yourself. So let's go dive into the lesson proper. You have tasted acid before, or let me give you an example. At one point at a time, you have tasted a lemon or a vinegar or an unripe orange. How does it taste? Your guess is as good as mine. It tastes sour. This shows the presence of an acid. Most foods are most foods contain acids, and examples are lemon, vinegar, oranges, etc. Acid tastes sour primarily, and this is due to the release of hydrogen ion that is dissolved in water. These hydrogen ions, when they are stimulated, they trigger the our taste receptors on the tongue. So the higher the concentration of the hydrogen ion in an acid solution, the stronger the sour taste. And that's why you observe that some foods are more sour than some other foods. Why? Because the level of hydrogen ion concentration or their acidity differs. So acid have sour taste. That's one of their physical properties. And then it's as a result of the release of hydrogen ion, which stimulates our taste receptor. Please don't forget that. Another property that another physical properties acid have is that they turn blue litmus paper red. In a simple experiment, if you have a dilute acid, for instance HCl, in the lab, all you just need to do is to put small portion, let's say 2 centimeter cube of the acid in the beaker, and then get a blue litmus paper. Just gently dip the blue litmus paper into the acid solution. What you will see is what you are seeing here. The blue litmus paper is turned to red, signifying the presence of the acid. So let's look at the chemistry of this. Acid turn blue litmus paper red because of a chemical reaction where the acid donates the hydrogen ion to the blue litmus pigment. Most blue litmus paper that you see are usually a dye or pigment. Which is when hydrogen ion is donated to that pigment, that blue pigment, the reaction causes the pigment to change its structure, altering the wavelength of light it absorbs and reflects. So it's able to change from blue to red. So this is why acid are able to turn blue litmus paper to red. The hydrogen ion, once again, the hydrogen ion change the hydrogen ion concentration in the acid changes the pigment from blue to red as a result of absorption and reflection that occurs in the process. Now, another physical properties of acid is that they have a pH that is less than 7. On the pH scale, you usually have 0 to 14. Now, between 0 to 6 is acidic. And then what we do is that between 0 to 3, you have very acidic. That means substances within this 0 to 3 range are very, very acidic. Examples of those substances are battery acids, the acids that are found inside a battery, for instance, your car battery. And then of course we have even lemon juice and vinegar. And then we have between 4 and 5 you have a moderately acidic, and then between 5 and 6 you have weakly acidic as well. So between 0 to 6, all substances that has this pH of 0 to 6 are usually acidic in nature. Why are they having a pH less than 7? Again, they release hydrogen ion into solution, making the solution more acidic, therefore lowering the pH. Acid release H plus. In fact, we use H plus to represent acid most times in chemistry. They release H plus into the solution, making the solution more acidic and therefore lowering the pH. So as they lower the pH, it indicates a higher concentration of H plus. So the lower the pH, the higher the concentration, or the higher the indication of high concentration of H plus. Now, another physical properties of acid is that they are corrosive. They can cause burns. They can even change the appearance of a particular substance. So, especially concentrated acid. Concentrated acid are very corrosive. So, it is very important to use glove and all other laboratory wares when dealing with concentrated form of acids. Now, another one is that dilute acid now, they can conduct electricity. For concentrated, like I've said the other time, that means they have more of this acid than the water. That's concentrated. But for the dilute, they have more of water because water has been added than more of the acid. But dilute acid can conduct electricity. Why? When an acid and water are mixed, because they are now dilute, they are mixed with water, the hydrogen ion joins with the water molecule to generate hydronium ion. That means you're having H plus from the acid plus H2O to give H3O plus. That is what is being generated. The hydronium ion is the one that is now responsible for the conduction of electricity in aqueous solution. So acid conduct, dilute acid conduct electricity. Another one of their physical property is color. Mineral acids are generally colorless liquid, except for dilute H2SO4, which at some point, when exposed due to oxidation and presence of impurities, may become yellow. You would have observed that you put a concentrated a solution of H2SO4 and leave it for some time, it might gradually turn yellow. This as a result of presence of impurities and oxidation processes. So dilute most acids that are colorless. However, organic acids like benzoic acid are white colored solids. So acids are generally colorless, with those, except for those few exceptions. And then again, we look at the solubility of acid. That's another property. That's number 7. Acids are generally soluble in water, especially the ones with lower molecular weight. The solubility of an acid is determined by its ability to form hydrogen bond with water molecule and its ability to dissociate into ions, thereby increasing the solution's conductivity. Of course, we know that water molecules are polar. That's they have two poles, H plus and OH minus, meaning that they have a slightly positive charge on the hydrogen atoms and a slightly negative charge on the oxygen atom. The polarity allows them to form hydrogen bond with other polar molecules such as the acid. Acids are generally polar in nature, and because water is polar too, they are able to form hydrogen bond. And hydrogen bond is usually responsible for the high boiling point and also the solubility of most substances. Now let's look at the summary of the physical property. Taste, litmus paper, pH, corrosiveness, conductivity, color, and solubility. Acids have sour taste, turns blue litmus paper red, pH less than 7. Many concentrated acid are corrosive. Dilute acid conduct electricity. They are usually colorless. And then organic solids are white colored. And then they are generally soluble in water. Let's go to the chemical physical properties of base. Now, that with this, you should be able to do your comparative study. Now, for bases taste bitter. Bases taste bitter. Again, look at acid; they have sour taste, but base have a bitter taste, and this is due to their chemical properties, and then the way our taste receptors detect them. Don't forget that we said that in our tongue we have taste receptors. For acid, our taste receptor help us know that they have sour taste. We are able to detect that as acid, but for base, it is bitter taste. It's a general characteristic of many basic substance, and this taste is one of the major things used to distinguish between an acid and a base. Secondly, bases generally have a slippery feel or a soapy feel. When you feel them, it look more like a soap, or they have a slippery feel. And this is an example you see in the picture. They are slippery in nature due to a chemical reaction that is called saponification, where the base reacts with fat and oil present on the skin to form soap. Alkaline hydrolysis of fat and oil is called saponification. This soap-like substance, they are the one that creates a slippery or soapy sensation when rubbed between the fingers. The soap-like substances created during this saponification process as a slippery texture, making the base feel slippery when touched. You can lay your hands on dilute base. You observe that they have some slippery structure. Or you can even put some in your palm, just more, and rub it on your palm. You observe that they are slippery. So they have a slippery feel. The next one is that they turn red litmus paper blue. Bases turn, that's the opposite of acid. They turn red. So if you get a red litmus paper and then you dip a solution of a base, for example NaOH, inside, you get a 2 centimeter cube of dilute NaOH, put it in the beaker and put a red litmus paper. Once you dip a red litmus paper and bring it out, you will see a blue color. So what is the chemistry behind it? Of course, in the case of a base now, they react with hydrogen ion concentration that is present in the red litmus pigment or paper, which are the acid form of the indicator. This reaction shifts the equilibrium, causing the indicator to take on its conjugate base form, which has a blue color. Acids usually release H plus in a solution, while base accept or combine with that hydrogen ion concentration. So red litmus paper usually contain a weak diapotic acid. So when a base is added to red litmus paper, the hydrogen ion from the red litmus usually combine with the base to form the conjugate base. So the conjugate base form of the litmus has a blue color. That is why you see that when you dip a red litmus, it generally turns to blue because the conjugate base form of that reaction has been formed. So generally, bases turns red litmus paper blue. And then of course they have a pH greater than 7. 7 is neutral, like we have mentioned in the pH scale. So you have between 8 and 9, we have a weakly basic. By 10, we have moderately basic. And in between 11 and 14, you have very basic substances that are there. You can see some of these substances that are around the baking powder, egg white, and so on. Now, what is the reasons for pH greater than 7? Because there is increase in the concentration of a hydroxyl ion or hydroxide ion, or of course, which it decreases the hydrogen ion concentration. The more the hydrogen ion, the lower the pH. And then when the hydroxide ion is more, it lowers that of the H plus, and that means the pH will have to go higher. That is why bases have higher pH. Another of their property is that bases are also soluble in water. The solubility of base solution actually differs. We have some, so we can categorize base based on solubility as soluble bases and insoluble bases. Soluble bases are also known as alkalis. They are the much more reactive bases like potassium hydroxide KOH, sodium hydroxide NaOH, and calcium hydroxide. The solubility of a base, however, can be influenced by the temperature, the nature of the base, and the strength of the base. In terms of strength now, we are talking about the dissociation or ionization power. Some of them dissociate completely in aqueous solution. Some of them dissociate partially, as the case may be. But if you increase the temperature of a solution of a base, it is likely to be more soluble in water. Strong bases are very soluble in water because they will dissociate completely in aqueous solution. Weak bases, however, they have lower solubility. Therefore, if you want to increase the solubility of a base, especially the weak bases, you can increase the temperature medium, and then they become much more soluble, as the case may be. So the solubility of base differs. The strong bases are very soluble in water, while the weak bases are not soluble in water. However, they can be made to if the temperature is increased. So let's look at the summary of the properties of a base. Taste. Bases have a bitter taste. They have a soapy feel. They turn red litmus paper blue. They have a pH greater than 7. They are corrosive. The concentrated form of base is also corrosive. So you can add this property to it. The concentrated form of a base is also corrosive. They also can conduct electricity. Why? Because they have two poles as well. So they can conduct electricity. Then the hydroxyl ion can also, when mixed with the OH, the OH when combined with water can also form the the hydronium ion. So they can also conduct electricity, and of course they are also polar. And then this one also make them to be generally soluble in water, especially for the stronger bases in them. And of course, stronger bases are called alkalis, and then they are usually colorless, except for hydroxide of copper and iron. They are usually colorless. This is summary of their physical property. So let's look at the chemical properties of both acids and bases. Both acids and base, they will react with metals. When an acid reacts with a metal, it usually displaces hydrogen from the acid. This leads to evolution of the hydrogen gas. So the metal will combine with the remaining part of the acid to form a salt. So generally, the reaction of a dilute mineral acid, take note, a dilute mineral acid with a moderately reactive metal. Please take note of those statements. The reaction between a dilute mineral acid and a moderately reactive metal will produce this metallic salt and, of course, hydrogen gas as the product. And then alkalis, that's soluble bases. We also react with moderately reactive metals, as e.g., zinc, to form sodium zinc oxide, and then, of course, hydrogen gas is also liberated in the process. Another reaction is that of reaction with metal carbonate or metal bicarbonate with acids. Now, metal carbonates like sodium triisocarbonate 4 usually react with dilute mineral acid again to produce CO2, which is the major byproduct gas. So the CO2 gas is liberated when a dilute mineral acid reacts with a metal bicarbonate or metal carbonate. Please take note of that. And of course, a salt, water, and CO2 is produced. Note that metal carbonates and bicarbonate generally do not react with base. Why? Because they are actually basic in nature. In fact, sodium carbonate is a weak base. So most metal carbonates are usually basic in nature. So they are weak bases. So they will not be able to react with another base. So there is no reaction typically. So they can only react with acid to generate salt, water, and CO2. Please take note. Number 3, metal oxide can also react with acids and base. Now, an example of metal oxide is copper oxide. Copper oxide can react with dilute mineral acid to produce the salt, copper chloride, and water. Again, some metal oxide can also react with a base. However, they must be amphoteric oxides. Now, observe that zinc oxide and aluminum oxide are amphoteric. Other metal oxide are basic in nature, so they will typically not react with another base. However, if that metal oxide is amphoteric, that means it can react with acid and base. Examples are the zinc oxide and aluminum oxide, like we said. So these are the ones that can react with a base and to form the salt and the water. Please take note of that. Then the next one is reaction of non-metal oxide with a base. Non-metal oxide can react with a base to form salt and water. Again, note that non-metal oxide like CO2 are acidic in nature. They are actually called acid anhydrides. So they cannot react with acid again because they are acidic in nature, but they can react with base to form salt and water. Again, let's look at a combined reaction of between acid and a base. A combined reaction between acid and a base. Acid reacts with a base to form salt and water. This is known as neutralization. Neutralization is a reaction in which an acid reacts with a base to form salt and water. An example is when you have sodium hydroxide and dilute HCl reacting with sodium chloride and water. What happens in this neutralization process? Number 1, the acid will release hydrogen ion concentration. When it's released in this aqueous solution, the bases will release OH minus. So for the neutralization reaction, the H plus is joining together with the OH minus to form the water molecule. So in a typical neutralization reaction, H plus combined with OH minus to form H2O. The remaining part is where you now have the salt. So the once H plus and OH is coming out from the acid and the base respectively, the other part of the acid and the base combine together to form a salt. So this is where acid and base meet for this type of reaction. So so far we have looked at about 5 chemical properties, and we have looked at least minimum of 7 physical properties of acids and bases. Now, your activity that you need to do here is to do a comparative study. You have to do a comparative study of the two. That means that in a tabular form, you are just going to say physical properties, acid, base, what it tastes, appearance, color, solubility, cohesiveness under the heading, and then you compare both acid and base for physical. Then for this chemical, you do the same. This will help you to get a full understanding of their differences and their similarities. It's important that you go through this activity. Activity 2 is just as a simple question. We are to determine. The question says, is a wire question. Which of the statement is false? Acid react with some metals liberating hydrogen. Acid react with carbonates liberating carbon dioxide. Acid conduct electricity and are decomposed by current, liberating hydrogen at the anode. Acid have a sour taste. Then acid change the color of indicator. Look at this question very well. Which one do you think is false? If you have done it very well, the answer is C. With a dilute solution of sulfuric acid and platinum electrode, hydrogen gas is evolved at the cathode. So hydrogen gas is evolved at the cathode, not at the anode. This is an example of electrolysis of acidified water, for instance. So at the anode, hydrogen ions are released to the anode, and then they lose one electron to become hydrogen atom, and they combine together to form hydrogen gas. But at the anode, the OH minus is released, is as accept electron and form water and oxygen gas. So hydrogen gas is produced at the cathode, while oxygen gas is produced at the anode. Why do we have this kind of question? You observe that we have talked about all of these properties of acid before, and all of them A, B, D, and E are correct. Only C is wrong in this question. So this is the end of physical and chemical properties of acid. So in a summary again, let's look at what we have said so far. We have talked about the chemical properties, that's neutralization reaction between acid and base. We've talked about reaction of non-metals with bases. We've talked about reaction of metal oxide with acid. And of course, we have emphasized that only amphoteric oxide can react with a base in this context. Yeah, we have also talked about reaction of metal carbonate with acid to produce CO2 as a byproduct of the gas, or as a byproduct, the gas that is a byproduct. We have also talked about the reaction of both acid and base with moderately reactive metals. We've looked at the physical properties of a base: the taste, feel, litmus, pH, cohesiveness, conductivity, color, solubility. And then we have also looked at the acid, the taste, the litmus, the action of litmus, the pH, corrosiveness, conductivity, color, and solubility. With this, I believe you have learned greatly about the physical and the chemical properties of acids and base. Continue to learn chemistry. In the next video, I will see you there. Bye bye.